I know, I was really kind as well today. I felt sorry for people just sat around talking. So I did put Pac-Man in there, but there's only me at the top of the leaderboard, followed by Gareth so far, and Gareth doesn't count. If there's a normal, if there is a normal like
a
attendee,
normal person,
he means me, right? He actually means me.
No vendor or leader.
A useless person.
That manages to get to the top, I might be able to scrape the bottom of the barrel of my swag drawer at home and see if I could post you something. Or a bottle of Dettol, one of the two.
Dettol. Good stuff. Cool. Right, yeah. So obviously there's a huge well, I'll let Dean cover that bit from a VMware perspective, but Kubernetes in general has been washed over us more so over the last 12 to 18 months than any other technology anywhere, and even more so because we're stuck at home. So one of the things that we did at Veeam, we've obviously stayed very much focused on that. You traditionally know Veeam for virtualization, VMware backups. But in October last year, we brought a company that focuses on data management within Kubernetes. And this is kind of a very high level look at what we do there. I keep calling them Kasten as if they're a different company, but what we do there, and just putting in a more demo than slideware so that we can kind of hopefully help, or we're all pretty much learning this new way, and about helping the virtualized admins to start to appreciate and understand what it is that and why you might go down that Kubernetes path, why you should be learning it, and then we'll get into a demo as well across that. So Dean, do you want to introduce yourself first, mate?
Yeah, no problem. Hi, everyone. My name's Dean Lewis. If you've been lucky enough to attend the London VMUGs before, you might have seen my happy smiling face around. I now work in the cloud management business unit as one of our specialists at pre-sales. I also do some little bit of flitting about with the office of the CTO, which basically means doing stuff like this in the field, which is why I'm here today. Follow me on Twitter, although according to Simon this morning, less people are on Twitter nowadays. And of course, like everyone else in the world, I have a blog, which is theeducate.co.uk.
Good stuff. Yeah, and for those that don't know me, I'm Michael Cade, and I'm a senior global technologist at Veeam. I sit within basically the product strategy group. So I sit in the same team as Anthony Spiteri that we just spoke about, and a few other guys in there that you probably know from the IT community. And pretty much the same as Dean, it's about spreading the news and helping the community is probably the first and foremost part of my role. Throw some stuff on vzilla.co.uk more for my memory and going back to referring to that so I don't forget it. It's basically my OneNote for life. As well as started some YouTube stuff this year as well. So really what we wanted to focus on was around the data protection challenges of Kubernetes. I think we all like to get the nice shiny new technology, and data protection, maybe monitoring, and there's a few other things that always drip down, especially from a budget point of view. We're always very close to the bottom when it comes to the exciting stuff. No one said backup was sexy, maybe ever. But so what we want to just kind of reiterate is it doesn't really change too much. Like as you're moving these different architectures, like you went from physical to virtual, maybe you've still got some physical, and you're maybe then thinking about going from virtual to like a container-based solution. Ultimately, it's not too dissimilar. The data is still most likely the most important part. So what we want to do is just give a very brief overview of what Kasten is, what it does, but more to the point, roll back on that, because I don't want to get into like, why is Kasten the best one for this? I want to kind of highlight the challenges around data management in a container or Kubernetes environment so that we could then answer that in our demo as well. So probably everyone's seen a variant of this, even if you're not like if you're at level 1 of your containers Kubernetes learning journey, you've probably definitely looked at how does it compare to VMs? And the biggest comparison, or the best comparison that I saw, was about from a virtualization point of view. Obviously, we virtualize the hardware, and that enables us to spin up multiple versions of virtual machines or different operating systems to provide us with our workloads, with our application servers, if you will. When it comes to containers, we're virtualizing the actual operating system. So we're getting more out of the operating system. We're sharing that operating system. So if you think about how physical was one box and it had your operating system on. Then we went into virtualization, where now we could fit 10 to 100 VMs on one physical host, one physical server, probably more in some instances. And now we've got containers, where we go that one step further, and we're virtualizing the operating system to get hundreds and thousands of containers possible on one virtual machine. And why has it progressed that way? And without like teaching you all to suck eggs, really it's about deployment, right?
Sorry, I couldn't hear what you said.
So tune into YouTube. So container deployments are very quick and streamlined in terms of, and I appreciate that some of virtual machines are extremely quick to deploy now, especially when we've got infrastructure as code and the capabilities around automation that enables that. But from a container point of view, we're now looking at megs rather than gigs of data just to spin up these workloads. And some of the things we're going to talk about over the next couple of slides is, okay, they're quick, they can be deployed very quickly, and they're configured extremely quickly. They're very secure, they're scalable, very easily upgradable, if that's even a thing, because generally you'll probably just take a new container and slot that into your workflow, into your workload. And then you've got over on the right hand side around the stateless, stateful. Now the stateless is probably where Kubernetes really latched on to where that it made sense. If you could have a stateless application where you're not writing anything persistent to a storage, you can spin them up, spin them down, spin them out. Like, the architecture makes sense in that. And then over that 12 to 18, maybe even 2 years, we've seen a much more increase in, or how about we run our databases in a Kubernetes environment or in a container environment. And then things like stateful applications, then it sticks to the host name and IP addresses, but also it's right into that storage. So that storage then becomes persistent. So when you then have to think about, I want to pull it down, I want to spin up a new version, you've always got to think about that storage part as well, and make sure that you've got that accessible to whatever that new storage is. And obviously that brings architectural challenges, or at least you've got to know about it. So I mentioned around physical to virtual to container, if you will. And again, it's different, but it's kind of the same. The same challenges are there. Like, if we need to recover a failed application to production, regardless of whether you're physical, a VM, or you're a container, the challenge is still the same. We still have to get it back up and running as fast as possible. Now, granted, the benefits of one or many of those options could be that it's a much faster way of being able to bring that up, especially if it's stateless. And that's another benefit of being able to use stateless containers. When you add in a database or something that requires that persistence, then that changes potentially what that looks like. We need to recover a failed application or a container to an alternate location. So i.e. take it from one Kubernetes environment and spin it up in a different, whether that's for recovery or whether that's for test and development. Obviously, that's the angle that Kubernetes really solves or enables, is that ability for failing fast and being able to update your workloads as fast as possible. We need to migrate applications for infrastructure lifecycle, exactly the same as the point before. We need to be able to move that workload from A to B. And that kind of is the same thing that we've been dealing with back from physical to VM and into the container world. I think the different, and you can read the rest of them. I don't want to read them all out individually, but the difference comes to that. And this goes back to when we first, I mean us as virtualization admins and consultants back in the day, these challenges were very much there because we had them in the physical world, and we generally lifted what we knew and what we did for those physical machines on premises, the agent-based backup approach, and we just adopted that inside of our virtual machine, and we just used agents. And then a little company called Veeam came along and they went, well, actually, let's go under the hood. Let's use the APIs, the native APIs of the virtualization hosts, and be able to pull the data out in a much more efficient way there. And it's that change that changes the mindset. It doesn't change the challenges, they stay the same, but the way in which you alleviate those challenges is what the important part is. And again, Veeam can back up the hosts. Like if you have Kubernetes hosts that are actual VMs in the world of Tanzu, then Veeam can back up those VMs, but we have no idea about the container constructs and all the artifacts that go with that. And that's where Kasten comes in, is that they do have the visibility because of where they live, and I'll get into that as well. But ultimately, is they were born to go into that operating system or into that orchestration level, rather than an agent going in and plugging in and just making do with how we work with virtual machines or how we worked with physical.
So I think
that makes sense.
I think that the biggest challenge, which I think might be covered on the next slide, we look at a virtual machine today, and a virtual machine is just a set of files. So even the hard drive of a virtual machine is a file on some storage somewhere. And we can protect the whole virtual machine and its operating system and everything, and rebuild it and move them blocks somewhere else and redeploy it and build it again. And as long as your VMX files configured correctly, the virtual machine will power on, because we're just emulating that hardware. With a container, it's not quite the same. So we pull down a container image and we run our processes on there. And Michael's right, we have somewhere to keep our persistent data. So in the case of a database service like MongoDB, we're going to point it at a mounted, what it thinks is a drive within its kind of little bit of its kernel. It's going to save that data to it. Now that's going to be backed by storage somewhere. But we don't back up that container image. We don't care about that container image, but we do care about the configuration. So how is it built? So if we think of a VMX file, which tells us how our virtual machine is built, you have YAML files, which tell you how your application is built. So what is your pod? So where is its image coming from? How are you going to link things to that image, like its storage? Do you need any secrets? So how does it authenticate to things? Do you want to provide any services to it, such as ingress? So today we are gonna use our mission critical application of Pacman. How do we access Pacman from the outside? We need a load balancer so I can scale up the pods for all of you lovely people to log in and not crash the applications. We've got multiple web front ends. And that's essentially the difference between using something like Kasten by Veeam today, rather than traditional virtual machine backups.
Yeah, and I think the three focus areas around those challenges is, one, how do we protect that persistent storage? As we see that number rising in terms of people moving into the container or Kubernetes world and requiring that stateful persistent storage, how do we protect that? How do we protect them individually? Because like Dean says, that it's not just a VMX or a VMDK file, it's all of the artifacts that are making up this whole application and understanding what that is. And that application could consist of 100 or 1,000 different containers as well. So having that visibility of that, and I guess another like for like would be around like a VApp. A VApp can allow you to control many different virtual machines within a pool of an environment. That could be kind of similar to this, is that we'll look at that as the application, and see all of the artifacts that make up that virtual or make up that application. And then obviously the big point to the challenges that we just touched on is, well, that's great that we can take all of that in a fashion that allows us to just store it, but we obviously need to be able to recover that and be able to recover individual artifacts as well. So we're not just going to bring back, or we could just bring back the whole application, but 9 times out of 10, it's going to be one thing that's changed. Like Dean mentioned about the load balancer. Well, let's protect the load balancer. And if we need to bring back one side of it or potentially some of it, then we can be granular about how we recover that. So then that gets us on to Kasten K10. And just again, very, very high level, is what it does is it discovers that whole application. So regardless if it's a MongoDB database and that's a container, a namespace on its own, it will discover that. Or if it's a full-blown web interface or a mission critical app like Pacman, then it will absolutely discover that as an application or as a group. Then policy-driven approach, so being able to leverage, and I'll get into this more in the detail, or Dean will, around policy-driven. So based on the application, based on tags, based on automation and understanding what makes up that application. Well, when do we need to protect that? Why and when? How do we protect that? Whether it's using the native storage underneath, but leveraging the CSI drivers, etc., to be able to capture that, or whether we're exporting that out to potentially a different location. Very easy to use UI, and we'll get into that. Both of us will touch on that. And then, yeah, from an architecture point of view, so if you think about kind of everything that I've just touched on, whether it's virtual, physical, cloud-based, wherever Kubernetes runs, we've got the ability to run Kasten. And that is because it sits within its own namespace within the same Kubernetes cluster that you're protecting. So, and that then allows us, and very similar again to how Veeam works today within a virtual machine environment, our VM, our management, could sit within the same environment. It could sit as a physical machine, but it has a hook in to the vSphere APIs to allow us to take those backups. K10's very similar to that, is that we plug in, we use the Kubernetes APIs. So everything that Kubernetes has the ability to do with the CSI driver, that's why Kasten doesn't care about what that underlying physical storage is. So wherever Kubernetes is, Kasten works. There are obviously some caveats to make there, but I'll get onto the documentation shortly as well. There's no proprietary storage layer because of that CSI driver. That's already been abstracted by Kubernetes, so we'll leverage that. So whether it's block storage provider, object, that's all dealt with via Kubernetes and the APIs there. And then the application footprint is understanding what that looks like so that we can capture that and being able to make application consistent versions of that application. So this is where Kasten sits in the open source network with a side project called Canister, which allows you to have that consistency across your application as well. So if everyone can just check whether that QR code works. Obviously, I went to this is where I spent most of my time on the slide deck, is on QR codes. So
see, look, you even put a little Pac-Man image in the middle of it. How cool is that?
I know. I'm selling my QR. Oh no, I'm not. I can't. It's someone else's service. But yeah, if you like, obviously some people have been playing that already. But now, if I stop sharing and I share my.
So whilst Michael's sharing his screen, if people want to change their little view so they can see me, 30 seconds. The top spot at the end of today with -VMUG at the end of their name on the leaderboard will be getting a Vanguard exclusive keyring. And currently there's only 10 of them in the world. One of them in use by me and one of them in use by a Royal Mail postage.
Yeah, the one that didn't get, they took mine instead.
Well, that's today's swag, is a Vanguard keyring.
They're very highly sought after. So just the idea here is, so I've just jumped into a Windows jump box. You can see over on the left-hand side, hopefully you can see that, is that I'm on my Kubernetes, I'm on my host, and I've contexted into my Kubernetes cluster. So if I now run kubectl get namespace, you can see that I've got my all my different namespaces in there. Now, what we're going to do is we're going to go ahead and we're going to go and create a new namespace for an install Kasten. So at the moment, we have no Kasten in here.
Before you install anything, Michael, you just need to change your context to the other cluster.
Oh, before I break everything.
Yep, you're in my Blue Peter cluster here. There we go. That one should work.
You want me to go to 1?
No, 2.
I was on 2.
Yeah, that command will work. There we go.
Whew, that was close.
I know, right? We'd have had to have restored everything back up.
Just to prove again that there is nothing, but there was a few more other namespaces on the other one, but there is no Kasten one. So what we're going to do from scratch, we're going to go and install that Kubernetes namespace and then install Kasten on there. So first of all, I'm going to take this and I'm going to create a namespace. Obviously nothing too taxing about that. Now I need to move this so that I can actually see the command. And what this command is going to do is going to pull down a Helm install or a Helm chart that enables us to go and install that. Now we're going to walk through what that is. So we're going to install K10, Kasten K10 in the namespace of Kasten-IO, which is what we just created. We're going to set an external gateway. Now this, like Dean mentioned, we're leveraging a load balancer because we've heard that there's many people wanting to try their luck at this Pac-Man, this mission critical system. So we obviously wanted to load balance that across the systems. There's also other options around port forwarding and being able to access the Kubernetes, the Kasten interface for this. We're using a load balancer. And then from an authentication point of view, we're going to use a token authentication, but this could be Active Directory, LDAP, etc. as well. So with that, we get that up and running, we get that going. And then if we go and have a look, once that, that was really quick. So that then gives us an idea of what is actually running in the Kasten-IO namespace. And you saw that pulls it down and then goes away and creates all of these containers that allow us to run for Kasten to run. Then we would go and get the SA secret, extract that token, take that token, and then we would authenticate into our cluster, which I'll touch on shortly. The other thing to mention is the documentation is for someone who really doesn't have or didn't have a clue and really still doesn't have a clue about Kubernetes. And the architecture that goes with that is this documentation is literally a handhold all the way through that. So you choose what platform you're wanting to run that on, and you can see pretty much it's agnostic. It runs on all, even if it's like on your own environment, it will run. So, and there's a pre-flight check that you run through to make sure that you've got all of the prereqs installed and ready, and then it allows you to pull down the Kasten repo, and then you go and ultimately it's the same everywhere. That Helm install K10 that you saw on the last on the last thing. So then when you first log in to that dashboard, obviously this is the Blue Peter moment. We already had this deployed on another cluster so that we didn't have any issues with rate limiting and not being able to access or get it up in time for the demo. So the first time you log in, you get this option to take this dashboard tour, but really it's quite simple. So first of all, I'm not going to touch on these because Dean will do, but I'm going to jump into settings. So when you first jump in, obviously that's Kasten. It's ready to start configuring where and what you're protecting. So at the moment, it did not, at this point, on a fresh install, it wouldn't know where we're going to export those backups to. It wouldn't know the infrastructure that you're sat on, etc. So one thing here is that we choose where we want to store our backups, so our exports in this world, in the terms that are used here. And you can see here that we've got Google Cloud Storage, Amazon S3, Azure, or any S3 compatible. Know that on a roadmap is the ability to send that to a Veeam backup replication repository as well. Obviously, it's not here today. It's something down the line. But you would ultimately put in your storage account name, your storage access key, your location, container, and Dean will touch on where that's used later on. From an infrastructure point of view, we need to point it to, well, where are we protecting this? So give it a name and then choose what version or what infrastructure we're using in there. I think that comes, it comes up with the same.
So at this point in time as well, you probably, for the eagle-eye among you notice that we're pointing this at a VMware Cloud and AWS instance. It's very versatile for a start in terms of, you know, what limitations are there, or do we need any special access? And the answer is no. And one of the things I will point out here at the moment, because it's kind of not really documented and will change in the future. So VMware's implementation of being able to access the underlying vSAN storage or VMFS storage or NFS storage exposed through the host, we will use a customized CSI driver, which can contain a storage interface. Today, as that stands, we do not support within the CSI. So this is whether it's Tanzu Kubernetes Grid using CSI for OpenShift or vanilla Kubernetes, for example. We don't support snapshotting the Kubernetes volumes themselves, which causes a little bit of a problem because how are we going to protect that data? You know, we use snapshots to protect data when we back up a virtual machine. So Kasten here does something very interesting, which is by using this infrastructure profile, it can talk directly to the vCenter. It can map out the first class disks. So these are the VMDK files that are created and used within the Kubernetes environment to use that underlying vSphere storage. And it can call a snapshot directly against them outside of the CSI driver today. In the future, VMware will produce support for that snapshot functionality within the CSI, and then Kasten will leverage one or the other. And again, as Michael's highlighting there, kind of it will go off and talk directly to the other platforms we can see listed as well. But as this is VMware user group today, we won't cover them.
Yeah, that's all I'll do is just highlight them. Then you've got the K10 disaster recovery, so the ability to enable another Kasten instance in a different location. So it allows you to send those snapshots over to that secondary location. Then licenses. So I think I'm going to touch on this later, is that you get 10 node, I think it's 10 free nodes, which is obviously that the underlying operating system that you're leveraging with your containers. So quite perfect for home labs, basically, is what I'm getting at. And then for those that didn't see on the slide, there is a dark mode as well for the interface, probably one of the biggest features that everyone gets or anyone that works in product. So yeah, that's a very brief overview of what Kasten is, what it does, what the challenges are from a data protection point of view. And now we can get into a bit of the mission critical application that we have. So I'll stop sharing, Dean, and you can
I can do something. Right. Okay. So let me shut everything down so you can't see all of me editing the Pac-Man scores in the background so that I still get the keyring. Ooh.
Save on postage.
Save on postage. What's going on? I seem to have. Okay, so I share that, so we should be able to see a command line terminal at the moment.
Yeah, I can see it.
Yeah, fantastic. Okay, so first and foremost, let's have a look where people are up to on the high scores for Pac-Man. Oh, Chris Bradshaw is the person going home with the Vanguard keyring at the moment, unless I think we might let Gareth sneak in there today to get it if he gets higher, and Catherine possibly might have a chance still. So we'll go back to the Kasten dashboard. It's pretty self-explanatory, pretty easy to use as well. So I'm just going to quickly reload this interface. It's not logged me out, so that's fantastic. So because this is our Blue Peter environment, I have already set up a policy just in case so that we don't look absolutely terrible if nothing works. the first thing we obviously want to do is protect our data. We want to protect that mission critical application. So we do that by creating a new policy. We give the policy a name, as we would expect. And then we choose one of two actions. So the first thing to know about policies, we have how do we protect our data. So Kasten today calls that a snapshot. We all know in the vSphere world that snapshots are not quite a backup, but we'll talk about that in a little bit more in a second. We also have that ability to import data as well from another system. So Michael talked about before setting up having our DR location. So we have Kasten running in multiple clusters to be able to move data between it. We can also import data from another location as well. So we can restore it. Very similar to how you go in Veeam and you rescan an old Veeam repository to bring that back up into a new Veeam instance. So let's protect our data. First things first, you're going to be, do everything on a schedule. We kind of all know what schedules are nowadays, so I'm not going to bore you to death. We can also set advanced options such as offsets, and we can also go further into that if need be, and how often we want to keep those snapshots for. We then move down. So where does it actually become a backup? Because at the moment we're snapshotting at the Kubernetes cluster layer. As I mentioned before, in vSphere, we're actually snapshotting at the vSphere layer for that first class disk. So how do we create it to a proper backup so that we're not just relying on snapshots living inside of our cluster, side by side with our original data? We would enable that backup via snapshot exports. And then we basically, again, choose based on that schedule, how are we targeting those snapshots and where are we moving them to? So we're going to move them to our Azure portfolio, into container storage there, and what retention period do we want? So again, we can differentiate those local snapshots inside the cluster side by side with our persistent data to where we're storing it externally in our Azure-based storage today. And what do we actually want to do? So maybe we don't want to move our snapshot data for whatever reason. You just want to maybe reference that data so that it could be used elsewhere when rebuilding a full cluster. To be fair, I think for most of us, we're probably going to stick with this main option here. And then we have some advanced options as well around the export settings. So within Kubernetes, we have this idea of storage class, a little bit like defining a storage policy within vCenter. So maybe your application is built for multiple storage classes, and there are certain ones you don't want to protect the data or export the data from for whatever reason. We can disregard them here for whatever reason. So maybe you want to not back up any data which is attached to Kubernetes-based storage policies, which are for test and dev data, for example. How do we actually select our application today? So we can do it by name. This actually namespace that Michael was showing us earlier. So in our demo earlier, as you can see on the left-hand side, I've already got a policy here called Pacman, and it's basically targeted at the Pacman namespace. In Kubernetes, one of the way that we identify things, especially when we're copying data, moving or manipulating data, is we use labels quite a lot. So think of these like virtual machine tags if we're going back to vSphere terminology. So we can look through all of those types of labels that are created. Some of these will be automatic, some of these will not be automatic. They'll be provided by your app developers themselves. So again, in my instance here, I actually created an app label name to identify my services, which are named Pacman. The difference being here, if I select the service name as Pacman, because this is a manually created label, I'm not going to back up my Mongo database because it's actually under a name Mongo. Now I can multi-select if I want, but again, if I want to capture everything, all of those configuration artifacts, I'm going to do the namespace. Then we get down to the final option. Oh, sorry, I've scrolled a little bit too far. So we then have the option of what resources do we back up? So these are looking actually at artifacts. We're interested today of everything, but we can also filter as well, and we can either whitelist or blacklist from that point of view. And we can basically say, how do we want to filter? Do we want to do it off labels again? So we could pick a label, but then look for sub-labels. We can look at particular resources, groups, or versions. Again, we can do that for excluding. And then finally, we have the option here of how do we use these canister options. So for those of you that have used Veeam before or other backup products that are available, as we know, when we protect a virtual machine, we have two protection methods. We have crash consistent, which is we capture the data as the virtual machine's running. And when that virtual machine comes back online, it comes back online as if it's blue screened of death, which is great, but sometimes the application doesn't like that and doesn't come back the way we expect it. And sometimes that can actually cause data corruption as well, especially when we're using highly transactional databases. So we then have the ability to do application aware processing. So this is telling the application that we're going to back up the data that it is using. This then will cause a temporary stun of the processes and the access to that data to allow us to protect it without causing any conflicts. Again, in Kubernetes, we may have the same requirements. So within Kasten, we have this open source part of the project, which is called Canister. And there's a number of actions available today that you could select around MongoDB, for example, MariaDB are the ones that come to mind at the moment. And it would essentially do the same things, application awareness at a virtual machine level. In this environment today, I don't have any set up, but essentially what you're going to do is you're going to tell it where those canister action settings are. So the configuration such, because you would tweak them as per your application. And again, what happens if those canister actions fail or do not run? And then we create the policy as well. One of the other really cool things in pretty much every single screen of Canister is you can click YAML as well. And this would give you the YAML file that you could go off and run at a command line level or an automation level to paste into your environment. Or if we're going to bring it back to VMware things, and I know we've got Sam on the call at the moment, we could even take this particular YAML and use it with, for example, something like VMware vRealize automation code stream, and use code stream to push these types of configurations as well with its Kubernetes integration to build protection policies on the fly when people create new namespaces, for example, in their environment, and use this as part of a CI/CD pipeline. Okay, so I've already created my Pacman backup. If I go back to my dashboard now, we can see that it's been running on the schedule, and we can actually see the types of actions that have been going ahead as well. We have backup options. So this is kind of that snapshotting piece. And we can see when they've run, how long it took, and how many artifacts are there. So today we can kind of see that it's saying pretty much the same. There's no real change from specs. But if we change that application, those specs would change. Well, let's say we have some extra config in there. We add a new service to be part of the deployment. I can click on this, I can go into further detail, and once again, I've got the options here to say, how would I get that data in the command line interface as well, or can I see that action as YAML as well? So this is consistent through those interfaces, and I can see the individual artifacts that we're protecting that make up my Pacman app today. And then we have this export action. So I just need to move the Zoom window because it's in my way. So then we have the export. So this is when we send this off to our external storage. So again, we see the same thing. We see the same data, and we see those items that are being sent off, those artifacts. Again, you would see some different here if you're using the filter options. And then at the top, we basically have this action where we can see are things running, are completed, and failed. And then finally, going back to the main part of the dashboard, we have this application view here. So we can see that there's 8 namespaces or applications that Kasten can see in our cluster that aren't protected, and 1 which is compliant. So if I click into this application view, we can see everything possible. And we can see here the reason why Pacman is showing as green because it's compliant with active policies. You can see there's 18 restore points there at the moment, and I can click through to see it again, all of those details. So let's destroy some stuff. So we're actually going to destroy the live environment that you're connecting to now. And I need to just find my right window with this on. It's there, it's a tab. So let's just double check who's the highest score, because we might have some unhappy people later on otherwise. So we have Andy Nashers, the swag king, who pretty much wins everything at the top there. So come on, Chris, you need to get in touch, get past him. I think what we'll do is we'll call a cutoff for the named winner to be 5 o'clock today, because I am actually going to kill this instance now and then fully restore it. So let's do that. So for any of you that were kind of really interested in what does this look like in my Kubernetes or Tanzu Kubernetes grid environment, pretty much everything we talked about today isn't unique to Tanzu Kubernetes from VMware. It is more just Kubernetes as a vanilla ecosystem of containers. But let's do a quick kubectl get all in my namespace of Pacman. And we'll quickly talk you through that as well. So I've changed context. That might be because of me and Michael messing around earlier. So let's go back up. There we go. We'll make this easier for you everyone again. So get all in Pacman. So today what you're actually live connected into is my pods all here. So each of these Pacman pods is my web front end running Node.js service for Pacman. In the back end, we have a single MongoDB instance, and that's connected to a volume on my vSphere environment, which is basically a first-class disk, so it's not actually dedicated to a virtual machine. And that's where it's storing the data for that database. It's made up of 2 external services, one for my Mongo database, so I can connect into this from my local machine to edit those stats to stop Andy from winning later on. And we also have the exposure for the Pacman behind this load balancer as well. And this is what I'm actually exposing them publicly through a netted IP address so that you can access the interface today. We have our deployment manifest. So this is how my actual app's built. What image are we using? How are we mounting things to it? Is there any particular permissions that it's running from as well? And then our replica sets are basically telling us how do we deploy this across our system? How is it deployed across my compute nodes in the environment as well? So that is everything that sits under my namespace. And the first thing we're going to do now is we're going to do kubectl delete namespace Pacman. And I'm going to double check the chat what's going on. Oh, so you wanted me to delete it just whilst Gareth was still higher than you. That's very well done there, Andy. A lot of competition. So we're just going to wait a couple of seconds for that to go through. Hopefully what should happen as well is if I go back to my Pacman instance, yep, that's not going to reload because Pacman's actually disappeared. Okay, and if I go back to my Kasten environment, so I'm still on that same application view, we can actually see that it's disappeared and there's nothing green on here. So that's not great. The reason why that's disappeared is because Kasten's actually realized that something else has gone on. So I'm going to change to list view just to make it a little bit smaller. We should start to see Pacman appear under a remove status because everything's disappeared. You say should, so it's not quite there yet. It's usually quite quick at getting this. Ooh, this is where, don't do live demos, kids. It never works the way you expect. There we go. You just have to click about a little bit.
It's
so we can
exactly
now see that.
as expected. You just
Yeah.
play into the camera.
Yeah, exactly. So we now see the reason why it becomes a removed application, because I've actually removed the full namespace rather than damaging a pod or damaging the one of the services or damaging the persistent volume and just removing that like we typically show. Just doing that really for speed, because obviously one of the things you need to think about is Kubernetes is decorative state. So if I tell it to damage pods or change a number of pods, well, that's not really a backup issue. That's just telling the configuration to, hey, scale up or scale down. If I tell it to use a different image, it's going to redeploy the pods with the new image. So maybe it's using a MongoDB image today, which backed by CentOS. Then I could tell it to use a MongoDB image backed by Ubuntu in the future. Is that really a backup issue? That kind of really depends. If I damage the underlying storage volume that the MongoDB is connecting to, well, the decorative state is going to constantly look for a new volume to attach that service to, and it's also going to, have some authentication requirements around there. So one of the things that I would need to do as part of my restore option would actually to just restore the data, but also then tell Kasten to basically scale down the MongoDB service so that we can restore that data and then reconnect the service to it as well. For all purposes of our Blue Peter, here's one I made an earlier demo. We're just removing absolutely everything in the environment to make it quicker and easier on me and to see less faults in the environment. So I click on this removed view. It shows me Pacman's there. I'm going to click to restore this application. And then it's pretty simple. So we can see I've got multiple backups in the past day. I'm going to go back to the last backup, which hopefully should still have some data in there for you, which is useful. And where do we pull this data from? We can pull it from our snapshot, or we can pull it from our exported location from Azure. So I'm going to go from our snapshot, and hopefully this should be quicker. It's going to give me details about that. So it was created 48 minutes ago. So unfortunately, some of you will have lost your high scores, but don't worry, get back on it. We know who was top and what score they had before it all went down. Where do we send it to?
I'll be top then.
So where do we actually need to send this data to? So again, the namespace doesn't exist anymore. So we need to create a new namespace. We're going to put it back in Pacman. We could even call this Pacman restored.
Well, yeah, and the other there, while that's doing that, Dean, is so we could call it Pacman restored, but then think about another use case in that Pacman clone. So then you can start to play with a clone of that. So let's forget about the delete that Dean just did, but now let's take that namespace, let's restore that from the last good snapshot or the last good backup, and then hyphen clone it, because then your developer team can use that, and it's all, the YAML will be there as well. So they could use that in part of their CI/CD to then go and say, oh, we need to change the amount of nodes, or we need to change the configuration.
Yeah, and again, we have these ideas of action hooks for post restore as well, of blueprints that can be run either on success or on failure, and we tell it how do we actually deal with that, what happens. So again, we could basically say restore this data, but previously we know we were running maybe 20 web front ends, maybe only restore it with 10. We could call off to external systems as an action hook as well to kind of notify into maybe our service desk and things like that as well. And we could do that through a various number of options. Moving down, we've got all of our artifacts. So do we want to select everything, or do we want to kind of not restore everything? For today, we obviously want to restore everything. And that's it. We click restore on this action and we confirm it. And then we can track that process in dashboard. So we can see we've got pending restore. And then as it starts to bring up all of that details and gets in touch with the vSphere API, it's going to start to restore that snapshot, the volume as well. And then we can see the action here that it's just kind of running and this dashboard's live. So whilst we're waiting for that to happen, one of the things that I just want to go back into is the options again for restoring the data. And I just want to show you something slightly different in restoring from the Azure environment. So as we go down, we have those same details. We see it's coming from the export profile of Azure that we created earlier in our under our settings for the cluster. If we scroll down, we can also click on these actions, for example, apply transformations. So I just want to get the restore out of the way to kind of save time. But one of the things we can do on here as well is we can create operations as part of those restores. So maybe we're now going to restore this into a different cluster, which uses a different storage backend. So maybe we're going to restore this into Tanzu Kubernetes grid running in native AWS rather than our vSphere environment. Well, the first thing that would come to my mind is the storage classes are akin to a storage policy is going to be different because it's not a vSphere environment anymore. So how do we deal with that? Well, we could create an operation to then change our paths or replace values. So we would replace that JSON value akin to the YAML configuration to say use a different storage class because it's going into a different cluster to restore as well. And there's a lot of options there. As you can see, we've got the abilities to test that paths exist, add values to JSON, remove values, copy things from one place to another, move, or just replace in our direct artifact itself. And again, we can target how we're doing that. And we can also, there's a couple of examples there as well. So we do actually have that example of changing the storage class. So here, if we click that example, it is targeting the resource, which is persistent volume claim. So that's what we call that storage artifact within a Kubernetes. And we can see here, the operation is going to be replace a path and a value, and then we give it the new value to change it to as well. And we can even test those operations. We go off and look to see if those values are even possible within the Kubernetes environment that you're restoring to. And you create that transformation as part of the, so we test that. it would basically tell me what happens. So I'd have to paste in my existing resource for testing in my new cluster and then bring it back. So I think if let's try this live and then move it across. So it tells me there's not going to be a match there because it's a deployment. But if I do Mongo storage, then we can see that it does match and it does work because the value we're changing here is that storage class name. So again, one of the great things inside of Kasten today is it will show you the changes that you're making when you do this. It will show you that YAML output. It will show you what's happening in your environment. I can then close that, and then my operation then would be to place, and then we can start to build up these as well. So that just shows you kind of some of the advanced options beyond just a point restore of the environment. And then, as we can see, as I've been talking, the restores happen. We can see the volumes come back. So the volume is actually 8 gig in size. And hopefully, so one thing that I've let it do is I've let the load balancer pick its own IP address, its own. Oh, so has that not restored? So this is where. Oh, sorry, I'm misreading. I thought it said restored. It's still telling me it's actually restoring application components there. So I was getting ahead of myself. But essentially, that's it now. That is Kasten in a quick, easy walkthrough, taking those concepts of what do we understand from backing up normal virtual machines. If a developer that's using Kubernetes comes and talks to me today as VI admin, what the hell does that mean? How do I protect my workload? What's different? What's the same? Essentially, if you need to use a backup product today, like Kasten by Veeam, it's pretty much the same as what you're used to from other backup products, typically Veeam. And yep, I think we should be able to see Michael's screens now.
Seamless.
Thank you very much, Michael.
So yeah, cheers, Dean. So I think hopefully that was kind of a nice sheep dip into some of the challenges that you're probably going to face if your businesses, your companies are going down this route. Now, obviously, from a community point of view, we want to learn and get ahead of that. So there's a couple of ways in which you can try that. So there is a hands-on lab, but there's also any Kubernetes environment you can use 10 free nodes to get up and running. Obviously, there's limited support to that, like community support. So very much similar to what we do from Veeam in all of the other products that we have, is there's always that community edition that allows us to play around and protect our home labs. So I wanted to highlight that one. And then Dean, do you want to touch on this one really quickly?
Yeah, so I'm also using my VMUG presenting time to steal the show with 2 slides to end my VMUGs with now. First one's first. So as you know, last year we hit a global pandemic. It kind of took us all by surprise. And I think none of us, especially in the UK, were expected to still be in the situation today. There are things you can do to help outside of directly working in medical science and helping your business still run. If you've got spare cycles, please help folding at home, which is where researchers upload work packages to understand protein folding, which is one of the key things that we're using to target the virus today. VMware are massively helping to support this effort, not only from making it easy to run on vSphere workloads in your home lab environments, but also on the back end, helping directly with the project today. And hopefully in the future, I'll be able to kind of tell you about some of those things as well. Next slide, Michael. Finally, it's already been touched on by Simon at the very start on the welcoming today. This is a user group. All of you here today are the user, even if you work for another vendor, even if you're the VMUG leader. We need a few things to be successful as VMware user groups, because this is at the end of the day, it's a community-based effort. We need sponsors to help us. When it's virtual, not so much. We need users, we need the community, and ultimately we need people to speak to you all today. Although me and Michael both work for vendors today, we're not kind of really doing this from a community level. We haven't tried to sell you anything today. We're not doing this from a vendor sales level. We're not trying to sell you anything today. We've done this as what's actually our interest, which is why we've chosen this subject today. Sponsors are great, but hearing from the community is better. My first event for VMUG and first proper speaking event was 2015 up in Manchester. And I spoke about how not to deploy VDI environments and learn from my mistakes when I was a customer of VMware's, and we screwed up a VDI environment on a mass scale. I've thrown up an old picture there of a really bad old dated Visio, that was probably Visio 2000 or something. And, the reception I got was great, and it was a great community to get involved with. We need more of this in the community. Anyone wants to get involved today, then please do get in touch with anyone that's presented. I'm sure we'll all be more than happy to help with you. I'm even happy to co-present with people, stand next to people when we physically do events as well, if you're nervous about it. Whatever you feel like you need to present, if you've got a willingness to do it, all of us here in this community, not just from the London VMUG, the Manchester VMUG, the user groups, we will all help you do this. We will all help you get on stage to do that, because we all started somewhere. Myself and Michael were terrible at presenting, many, many years ago, when now we're 2 or 3% better than we were 5 or 6 years ago.
I think I've got worse, to be honest, but that's a topic for another time. Yeah, I think there's loads of resources in there. It was meant to be a very high level overview of, and kind of liken it to the world that we live in from a virtualization standpoint today, and how this is moving. So hopefully that was useful. Hopefully you know where to find me and Dean if there are any questions, deeper questions about that. I'm interested as well. Part of my role is feedback from the community. As much as I get to speak to customers about feedback, I think we're a lot more honest in the IT community about what it is and what we want to achieve from it. And that just echoes what Dean was just saying, right? About being able to tell your story, like stand up, walk through something that you've achieved, that you've learned from. They're all valuable lessons. So yeah, with that, thank you very much. I think it's Chris taking over now, right?
I believe so. Fantastic. Thanks, gents. That was.
I figured out why Patman's not working. It's because it was restored on the wrong IP address, and when I did the show namespace, nobody pointed out that I'd put it into a different namespace name. So I was still looking at Pacman, not Pacman restored. So give me 2 minutes to change the NAT, and it'll be.
He's speaking English.
He's turning off and on again, Linda. It's
just
fine.
wait, just wait
Right,
3 minutes,
you.
Linda, and you'll be on.
Just bear with me while I rename
I
file.
lost my high score. That's what it was. Sabotage for
But
Andy.
I made no bones about it. I was definitely changing them back end scores so Andy and Gareth weren't.
That's a decent beard you got going on there, Mr. Lewis.